For this problem, go ahead and you can pause it and write down what I have, draw the picture and whatnot. So we're going to start out with what it says. Line TA bisects angle RTE. RTE is this big angle, so this bisects it, which means it cuts the angle in half, which means they are congruent to each other, and are they the same. So we're going to do that to show that they are equal. Now it gives you the measurement of angle RTE in a linear form, 3y minus 4. So this right here, this angle, this side of the angle, equals 3y minus 4, and ETA, which is the other side, which is this one, equals 4y minus 17. And you're trying to find the measurement of RTE, the entire angle. So what we're going to do, since these are the same, we are going to set them equal to each other. We're going to set the measurements equal to each other, which will look like this. So you have the measurement of RTA is equal to the measurement of angle ETA. And so we're going to substitute in their linear form. So you have 3y minus 4 equals 4y minus 17. What we're going to do next is now you're going to solve for y. So I'm going to not worry about any negatives, I'm going to move the 3y to this side. I'm going to move the 17 to this side. So I would subtract 3y from both sides, and then I would also add 17 to both sides. So this will give you 13 equals just y. So now you have your y. So now what you're going to do is you're going to plug it back in to both measurements. We're going to go ahead and get the degrees for both angles, and then we can just add those degrees together to get the measurement of the entire angle. So measurement of angle RTA equals 3 times y, and up here your y is 13. So I'm going to put 13 inside of that parentheses, and I'm going to subtract 4, which is going to give me a total of 35. And then measure of angle ETA equals 4 times y, and we found y to be 13. So plug in 13 again, minus 17. And that as well is going to give you 35. So that's just proving again that it was an angle bisector, and it bisected it right in half. So now what we can do is we can add that, because measure of angle RTA plus the measure of angle ETA equals the measure of angle RTE. So you have 35 degrees plus another 35 degrees, and that gives you a total of 70 degrees. So the measure of angle RTE equals 70 degrees. So this next problem that we're going to do, instead of using an angle bisector, we are going to use a median. So this is triangle TRE, and it says that line TA is a median of that triangle. This should be. So this is a median, and a median, it means that this splits this line and this whole segment in half. So this, just like with the angle bisector, those two are going to be the same. So angle side, well, segment AE says it's equal to 3x minus 11, and then AR is x plus 5. Now you want to find the measure, I want you to find the measure of AE, AR, and ER. So you have to find the individual parts and then the whole part together. So kind of like what we just did, except we're doing lines and we used x instead of y. Since both of these are the same, we can set this equal to each other, because AE equals AR, because this TA is the median. So then you plug in. So 3x minus 11 equals x plus 5. Just like that. And we're going to subtract over just like we did in the previous problem. So then I'm going to subtract x, add 11, and that is going to give me 2x equals 8. Well, equals 16, my bad. And then that'll give you x equals 8. So then we're going to plug the x in to both AE and AR, and then we're going to add both of those sides together to get the whole side. Alright, so we'll do AE. So AE equals 3 times x, which was 8, so I put that in parentheses, minus 11. And that gives you 13. And now we're going to do AR equals x, which was 8, plus 5. And that also gives you 13. It makes sense because the median splits the opposite side in half. So both of these should be the same length, and they are. And we just proved that. So now we're going to now we're going to do the whole side. So ER equals AE plus AR. So ER equals 13 plus 13, and that gives you 26. So the side ER is 26. For this final problem, we have 2 medians, just like that. So you have triangle ADC as your very big triangle, the big triangle, the main one, and line DB and line AE are medians within the triangle, which means the median splits the opposite side in half. So AC is split in half at B. So both of these are the same. Now, same on the other side. AE split the side CD in half. So this is going to equal this. That side is going to equal that side. And they gave you BC, which is this part right here, equals 6y plus 10. And this part AB right here is y squared plus 3y. Yes, we have a quadratic, but we'll work through it. And then part ED right here, this part, is 2x plus 60. And then CE is right here, 6x plus 12. So what they want us to do is they want us to find x and y, and then they want us to find all of these. Alright, so we're going to start with x. So I'm going to do that. This is how we're going to do x. Okay, so we're going to use the two parts that have x in it, which is the ED and the CE, which makes sense because they're both along the same side. And since they are both the same, we're going to set them equal to each other. So you get 2x plus 60 equals 6x plus 12. And then we're going to subtract 2x, subtract 2x, subtract 12, subtract 12. So you're going to get 48 equals 4x, which your x becomes 12. Alright, now we're going to do y. So, since these two are equal to each other, AB is equal to BC, then we're going to set these equal to each other. So you have 6x, 6y plus 10 equals y squared plus 3y. I'm going to move everything to the right side of my equal sign to not have to worry about any negatives. So we're going to just subtract everything over. So you're going to get 0 equals y squared. 3 minus 6 is negative 3. So we're going to do minus 3y, and then subtracting 10, you're going to get negative 10. Now, I'm going to show you 2 ways to solve this quadratic. We're going to do a factoring method, and then we're going to do the quadratic formula. So I'm going to do some little branches. So first what we're going to do is we're going to do the quadratic formula. And so how you do that, you do opposite of b. b right now is negative 3. So the opposite of negative 3 is 3. So, but we'll write it like this. Negative, because that always means opposite of b itself. and then you're going to do plus and minus the square root. Now b squared is negative 3. Well, b is negative 3, and you have to square that. No matter what, it's going to end up being positive, and that gives you a 9. Minus 4ac. So you have 4. Your a is 1 because there's no coefficient on the y squared. And then your c is negative 10. All over 2 times a. And again, your a is 1 because there's no coefficient on the y squared. So we're going to simplify this a little bit, and we'll do it step by step for you. So we have 3 plus and minus 9, and all of this becomes a positive 40. That's looking a little good. That looks really good. And then 2. So we now have 3 plus or minus square root of 49, which is a great number to have under the square root, all divided by 2. Now the square root of 49 is 7. So 3 plus and minus 7 over 2. This plus or minus you cannot ignore, because you have to separate it even more and do 3 plus 7 divided by 2 and 3 minus 7 divided by 2. So it really does matter that you have it. So this right here, 3 plus 7 is 10 divided by 2. That will give you 5. This right here is, the top is going to be negative 4. Now don't worry about the negatives, because they may or may not work, and we'll figure that out when we try and solve for the lengths. So we have negative 4 on the top divided by 2. So we get a negative 2. So these would be our possible y values. So that was the quadratic formula way. Now we're going to do a factoring way. So I see this, and I look about what can make 10. Well, 10 and 1, and then 5 and 2. Which of those could be added or subtracted to give you 3? Well, 10 minus 1 would be 9, and 10 plus 1 would be 11. That's not 3. So I'm going to go with the 5 and 2, because 5 minus 2 is 3. Now you have to be careful with the negatives. If the last term, c, is a negative, that means you have a plus a number and a minus a number. So we're going to do 0 equals, and you have two quantities. And since we decided that since c was negative, we're going to have a plus and a minus. Alright? Now, to make sure this number is negative, we need the bigger number out of 5 and 2 to be negative. So, which leaves us with a 5. So the 5 will be negative, because think about it. Negative 5 plus 2. That's negative 3. And so the first terms are just going to be y. Now, you look at this, and you split it up even more. So 0 equals y plus 2, and 0 equals y minus 5. Now you would solve this like any other equation. So you would subtract 2 and subtract 2. So negative 2 equals y, and then you would add 5, and you have 5 equals y. Aren't those both the numbers we got down here? It was a little less work, but you get the numbers either way. Alright, so now we have those two y values, and we have our x value. Alright, now again, with you getting a negative y value, it could work. It could end up working out in the end, but we don't know yet until we start plugging in numbers, which is what we're going to do next. Because it asked us to find BC, AB, AC, ED, and CE, and CD. Alright, so let's start out with this first one, BC. That will hopefully help us figure out which of these two is really going to be the y value. So, let's see, BC equals 6, and we'll do two different ones. Let's start out with the 5. Y, we're going to use 5 for this one, plus 10. And now for this one, BC equals 6, and the other y, negative 2, plus 10. So we're just going to go ahead and solve this out. So this will give me a 30, plus 10, 40. This one will give me a negative 12 plus 10, which is a negative 2. Well, can lengths be negative, like the length of a side? They cannot be negative, which means that the negative 2y value that we found doesn't work. And the only way we found out that it didn't work was plugging it in and finding out if any of the values would be true. So we can go ahead and eliminate the y equals negative 2. So now we know that the y value has to be 5. And so there's BC. So this one does not, we can't use that. So this length, this side BC is 40. Now hopefully we get AB to be the same, because they should, because we just said that they should be congruent. Alright, let's try it. AB equals, right up here, y squared plus 3y. Now we have y is 5, because we decided that we cannot use negative 2. So that squared plus 3 times y. And that'll give you 25 plus 15, which equals 40. As it should, because BC is equal to AB. So that these are the same is a very good thing. So now we're going to do the entire side AC. So we have BC plus AB equals AC, right? So we have 40 plus 40 equals 80. So that is the entire side AC. So those three sides use the y value. We haven't used the x value yet, have we? No, because the x value is used in the other side. So now we're going to do those three. So we're going to start out with ED. And ED states up here that ED is 2x plus 60. So we have 2, and our x value that we found was 12. So 2 times 12 plus 60 equals 24 plus 60, which equals 84. So ED is 84. Now hopefully we get the same answer for CE, because we said that CE is equal to ED. Let's find out. So we have CE equals 6x, so our x value is 12, plus 12. So 6 times 12, 72, plus another 12, which gives us 84. Phew, good thing. That just goes ahead and proves that ED is equal to CE, as it should be. So now for our final side, our whole side, CD. Now CD, just like AC was, you added both of these together. We're going to do that same thing for side CD. So side CD equals ED plus CE, which equals 84 plus 84. And so CD equals 168. All right. Those are your review questions.